little bit more now about type 1, type 2 errors, and so on and so forth. Okay. Suppose that the null hypothesis of a situation is that the victim of an automobile accident is alive when he arrives at the emergency room of a hospital. Now, what is a type 1 error? Type 1 errors occur when the statement is true. Okay, so he arrives at the hospital alive. The emergency room thinks the victim is dead when in fact the victim is alive. See, in a type 1 error, you reject the null even though the null is true. Remember, type 1 is always the null is true. Type 2 is when you fail to reject when the null is false. So in other words, the emergency room crew does not know the victim's alive when in fact the victim is dead. Does not know if the victim is alive when in fact the victim is dead. So alpha is the probability that the emergency room thinks the victim is dead when in fact he's alive. It's the probability of a type 1 error. It's not the type 1 error itself. It's the probability of it. Beta is the probability that the emergency room doesn't know if the victim is alive when in fact the victim is dead. The probability of that, not the event, the probability of it. Clearly, the error with the greater consequence is a type 1 error. If the emergency room crew thinks you're dead and they don't treat them, you could have a whole bunch of problems. So suppose the null hypothesis is a patient is not sick. Which type of error has the greatest consequence? Type 1 or type 2? Little stop and start here. Well, a type 1 error is when you reject the null when it's really true. So you believe the patient is sick when he's really not sick. If we had to classify, it's not 100% true, but if we had to classify, in the typical household, that's kind of like how mom would look at sickness. You get the sniffles and mom is like all over it. She is going to make sure that you're healthy. Even if you're not sick, she's still going to do something about it. A type 2 error, well, that's more like a dad error. The type 2 error is they don't reject the null when it's even false. You believe the patient is not sick when he really is sick. And I can tell you that I, as a dad, was guilty of that. My kids might say, Dad, I think I'm going to throw up. I think I'm sick today. And I go, so knock it off. You're going to school. Don't even think about it. Make it happen. Shake it off. You're going to be fine. Middle of a wrestling match, and my kid would come up and go, oh, man, something's wrong. No, it's not. Get out there. Go wrestle. So that tends to be more of a dad issue, particularly with the dads of athletes. Clearly, if mom's wrong, it's not a big deal. If dad's wrong, you could have a problem. So type 2 definitely has the greater consequence in this situation. I make light of it, but what you really need to understand is that a type 1 error is when you reject a null statement when it's actually true. In other words, you believe the patient is sick when he really isn't sick. Remember, the null statement here is the patient is not sick, okay? And the type 2 error is when you don't reject it when it's false. So if he's really sick, then the null is false because the null was he's not sick. So when he's really sick, the null is false. And you should reject it, but you don't, okay? All right. So let's read through example 9.7 here and kind of look at type errors a little bit more. It's a boy. Genetic labs claim to be able to increase the likelihood that a pregnancy will result in a boy being born. Boy, oh boy, come in the Middle Ages where you had kings and queens, they would have loved to have known about It's a Boy genetic labs. They wanted sons. Statisticians want to test the claim. Suppose the null hypothesis is It's a Boy genetic labs has no effect on gender outcome. Then a type 1 error results when a true null hypothesis is rejected. In the context of this scenario, we would state that we believe that It's a Boy genetic lab influences the gender outcome, when in fact it has no effect. Remember, the null is true, and the null is that it has no effect. So the null is true, it doesn't have effect, but our error is believing that it actually does have an effect. The type 2 error is when you fail to reject a false null hypothesis. In context, we would state that It's a Boy genetic labs does not influence the gender outcome of a pregnancy when in fact it really does. Now, the probability of the kind of mistake associated with a type 2 error is beta. Remember, Beta is the second two letter in the Greek alphabet. It goes alpha, beta. That's, by the way, where we get the word alphabet, alpha, beta, alphabet, the letters. I don't know if you ever knew that, but that's where it comes from. A type 1 error is denoted by the Greek letter alpha. Alpha's first, so that's the letter that a type associated with a type 1 error. The error of greater consequence would be the type 1 error, since couples would use, hey, it's a boy genetic labs, thinking that they're actually increasing their chances of having a boy, when in fact, they were not. So now we've got a try it kind of question here. Red tide, this is a real thing. Having spent my youth all the way up until I was 55 or 6 years old on Long Island, except for 4 years in college, I can tell you that we experienced several red tides. It's a bloom of a poison-producing algae, a few different species of a class of plankton called dinoflagellates. When the weather and water conditions cause these blooms, shellfish, such as clams living in the area, develop dangerous levels of a paralysis-inducing toxin. In Massachusetts, the Division of Marine Fisheries monitors the levels of the toxin in shellfish by regularly sampling the shellfish along the coastline. If the mean level of toxin in clams exceeds 800 micrograms of toxin per kilogram of clam meat in any area, they shut down the clam harvesting. They ban it until the bloom is over and the levels of the toxin subside, returning to safe levels. Describe both a type 1 and a type 2 error in this context and state which error has a greater consequence. Now remember, you need to come up with a null statement first. I'm going to give you a little stop and start, and then I'll show you what I came up with for a null statement. So my null statement is that the mean level of toxin is less than or equal to 800. Now, I want to see that the test does not exceed 800. And remember, the equals part always goes with the null statement, the statement you could nullify. So it has to be less than or equal to 800. Okay. Now, figure out your type 1 error and your type 2 error. Go ahead. Stop and start. Type 1 error is when you reject a true null hypothesis. So, in this case, you would believe that the test exceeds 800 when in fact it does not. In other words, you reject that it does not, when in fact it really does exceed it. I'm sorry, it really does not exceed it, okay? So, you are rejecting a true hypothesis. The true hypothesis is that the mean level really is less than or equal to 800, and you think it actually exceeds 800. The type 2 hypothesis, or type 2 of error, is that you don't reject it when it's false. So you believe the test does not exceed 800, you don't reject it, when in fact it does exceed 800. Now, which error is greater? Clearly the type 2 error has greater consequences, as since you didn't reject it, those clams can be harvested, sold to the public, and then the toxin can be introduced. Okay, only do the A part of this particular problem. We will have on future homeworks parts B, C, and D. Go ahead. Okay, so for letter A, you're choosing, a type 1 error is when you choose to reject the null when in fact it is true. A type 2 error is when you choose not to reject when in fact it is false. If it's false, you should reject it. So, as far as letter A goes, it's type 2 because you are not rejecting the null and the percentage is actually less than 88%. Okay? You're supposed to have at least 88%, and the null is wrong. It's false because you have less than, and you didn't reject it. Okay? All right. So there's some review of type 1 and type 2 errors with a little bit of alpha and beta sprinkled in.